Welcome back. Today we're going to now talk about writing parallel and perpendicular lines. So the other day we were just figuring out if they were parallel and perpendicular. Now you're actually going to take something and turn it into an equation in y equals mx plus b form. So make sure you go ahead and write down your table of contents, and then I need you to go ahead and flip to that page, and I'm going to have you go ahead and write that information down. Please make sure you're titling your papers so that way when I do your note checks, it's easy to find. And go ahead and write this down, and then once you have it down, unpause the video. Okay, so from the other day, I need you to remember or recall that parallel have the same slopes, and perpendicular have opposite reciprocal slopes. Okay, now remember opposite reciprocal just means change the sign, flip the fraction. Okay, so first thing we're going to talk about is writing parallel lines. So I'm going to go ahead and show you. We only have 2 examples of this style, and then we'll have 2 examples of perpendicular. So if you want to go ahead and pause and write all this down, you can, so that way you'll have it ready. The first thing you're going to have to do is get the slope of the first line. So you got to just tell me what slope is. And then you're going to use that slope and the point that they give you in the problem and plug it into your point slope formula, which is y minus y1 equals m times x minus x1, which y'all worked with this formula, and y'all seem to be doing okay with it. So let's look at these examples, and I'll explain these 2 steps. Okay, give a parallel equation to y equals negative 4x plus 1 that goes through negative 2, 7. Okay, the first thing I need you to do is look at your equation. Is it in y equals? If it's in y equals, you already have step 1 done. So I'm going to say step 1. The slope, you just need to tell me what the slope is. Well, the slope of this line is negative 4. Okay, now step 2, we're going to take that slope and the point that they gave me, negative 2, 7, and we're going to plug it in to this formula. So we're going to do y minus, and the y in the point is 7, equals m is negative 4 times x minus, and the x in the point is negative 2. Okay, first thing I'm going to do is change my double negative and distribute. Negative 4 times x is negative 4x, and negative 4 times 2 is negative 8. I'm going to bring down y minus 7 equals, and to get y by itself, I must add 7. When I add 7, I get y equals negative 4x, and negative 8 plus 7 is negative 1. Okay, this is my new line. Now, here's what I need you to do. I need you to check that the slopes are the exact same number, but that the y-intercepts are different. If you have the exact same y-intercept, you didn't write a different equation. You wrote the same one. So make sure that your y-intercepts are different. This one's negative 1 and that one's positive 1. Okay, now example 2, you're going to have to do a little bit more work on this one. Not hard work, just more work. I need you to give a parallel line to x minus 3y equals 9, and it has to go through 3, negative 1. Well, the first thing you're going to do is look at this equation. It must be in y equals. So it's not in y equals. So I actually have to find the slope. So I'm going to get y by itself. I'm going to move the x by changing the sign. That gives me negative 3y equals negative 1x plus 9. And then I'm going to divide by the number in front of y, which gives me y equals 1/3 x minus 3. Okay, so now that I have this in y equals, I have step 1. Step 1 is the slope. The slope is 1/3. Step 2 is to use the point they gave me, which is 3, negative 1, and plug into that formula up there. So I'm going to plug this in. Y minus, the y in the point is negative 1 equals, the slope that we found was 1/3 times x minus, and the x in the point is 3. I'm going to change my double negative and distribute. 1/3 times x is 1/3 x. 1/3 times negative 3 is negative 1. Bring down y plus 1 equals, and now I must subtract 1 to get y by itself, so that gives me y equals 1/3 x minus 2. Okay, now look at your equation you just came up with and the equation you solved for. Make sure they have the exact same slope, but different y-intercepts. And if they do, you probably have it right. Okay, now I need you to flip to the back of this paper. And I'm going to go ahead and have this all showing. And you can pause and write this down. These are the last 2 examples, and then we're done for the day. So pause and write those 3 things down, and then I will get started. Okay, so when we're writing perpendicular lines, it now has 3 steps. You must first find the slope, just like what we did before. So make sure it's in y equals. And then step 2, you need to make the slope the opposite reciprocal. That means change the sign, flip the fraction. And then step 3, we're going to do the exact same thing we did before, but now we're going to use the new slope and the point and put it into point slope formula. This y minus y1 equals m times x minus x1. Okay, so starting easy, and then we'll have a harder one. Give a perpendicular line to y equals 2x minus 4 that goes through 4, 3. Okay, the first thing you have to do is make sure it's in y equals. If it's in y equals, step 1, you need to find your slope. Well, your slope is 2. Okay, step 2, you need to make the slope the opposite reciprocal. So I'm going to make the slope perpendicular. So I'm going to put perpendicular in. To make it perpendicular, you must change the sign. So it was positive, I make it negative, and flip the fraction so it becomes 1 over 2. Because remember, this is technically 2 over 1. Okay, and then step 3, use the point that they gave you, 4, 3, and plug into this formula. So I'm going to put a little bracket around 2 and 3 because those are the things that I plug into that formula. So we're going to do y minus, and the y in the point is 3, equals the slope I must use is the perpendicular slope. So negative 1/2 times x minus 4. There's no double negative, so I straight to distribute. I get negative 1/2 x, and negative 1/2 times negative 4 is positive 2. I'm going to bring down y minus 3 equals, and to get y by itself, I must add 3. So I get y equals negative 1/2 x plus 5. Now, this one's going to have a little bit of a different check. When you go back to your original line, you need to make sure that the slopes are opposite reciprocals. And if they're opposite reciprocals, you have solved it right if you did your steps correctly. Okay, for example 2. Oh, my bad. There we go. Okay, now I need you to give me a perpendicular line to 5x plus 3y equals negative 21 that goes through negative 5, 1. Okay, so first thing, this is not in y equals, so I must get it in y equals. Move the x by changing the sign. That gives me 3y equals negative 5x minus 21. Divide by the number in front of y, so we're dividing by 3. And that gives me y equals negative 5/3 x minus 7. Okay, now that you have this in y equals, you've got step 1. Step 1 is to find your slope. Well, slope is negative 5/3. Step 2 is to find the perpendicular slope, the opposite reciprocal. So if it was negative, I make it positive, and I flip my fraction to 3/5. So I went negative to positive and flipped the numbers. Step 3 is to use the point that they gave you, negative 5, 1. I'm going to put a bracket around 2 and 3 because that's what I'm plugging into this formula up here. And we're going to do y minus, the y in the point is 1, equals the m I'm going to use is 3/5 times x minus, and the x in the point is negative 5. I'm going to fix my double negative and distribute. 3/5 times x is 3/5 x, and 3/5 times 5 is 3. Bring down y minus 1 equals, and we are going to add 1, and that gives me y equals 3/5 x plus 4. Okay, when you go to check this one, make sure you go back to the line you came up with and make sure just the slopes are opposite reciprocals. If you have any questions, let me know.